You may be very much familiar that our universe is completely dark. There are many predictions of light that may be coming from other comets or meteors. Although sun is the main source of light, there are many other sources of light in the galaxy. Now you may be wondering that how is that possible? Well, keep watching Gateway to Knowledge to know how a recently discovered comet has its own light. If you look on our Earth, then the northern and southern lights, which are collectively called as aurora, are generated when electrically charged particles speeding from the sun hit the upper atmosphere to create colorful shimmers of green, white, and red lights. But in the solar system, Jupiter and some of its moons, as well as Saturn, Uranus, Neptune, and Mars, have all exhibited their own version of northern light, but the phenomena had yet to be documented into comets. The Rosetta Spacecraft that is sent by NASA is one of the most traveled and accomplished comet hunters. It was launched in 2004 and it orbited the comet 67P from August 2014 until its dramatic end of mission comet landing came to an end in September 2016. The data that scientists collected from this was named as dayglow, a process caused by photons of light interacting with the envelope of gases known as the coma that radiates from and surrounds the comet's nucleus. But the new analysis of the data paints a very different picture. The glow that is surrounding the comet 67P is just of one kind, and if we link this data from the previous Rosetta's instrument, we will be able to get a better picture of what is going on. This has enabled us to unambiguously identify how Comet 67P's ultraviolet atomic emissions come from. The data indicates that the 67P's emissions are actually auroral in nature. Electrons streaming out in the solar wind are basically a stream of charged particles flowing out from the sun, and it interacted with the gases in the comet's coma, which is actually the nucleus of the comet, and it resulted in the breakage of water and other molecules. The resulting atoms give off a distinctive far ultraviolet light, which is invisible to the naked eye. This is because far ultraviolet light has the shortest wavelength of radiation in the ultraviolet spectrum. By exploring the emission of Comet 67P will enable scientists to learn how the particles in the solar wind changes over time, something which is crucial for understanding the space weather throughout the solar system. By providing better information on how the sun's radiation affects the space environment, it could ultimately help us to protect satellites and spacecraft as well as astronauts traveling to Moon and Mars. Rosetta is actually a gift which has given us a huge amount of information, because after it returned over its 2-year visit to the comet, has allowed us to rewrite the book of these most exotic inhabitants of the solar system. But how does this spacecraft actually detected the ultraviolet light? The ion and electron sensor instrument detected the amount and energy of the electrons near the spacecraft. Similarly, the ELICE instrument measured the ultraviolet light emitted by the aurora, and the microwave instrument for the Rosetta orbiter measured the amount of water molecules around the comet. This mission has helped us to reveal that the Comet 67P has its own far ultraviolet light. It is the first time that such electromagnetic emissions in the far ultraviolet light have been documented on a celestial object other than a planet or moon. So that's all from my side. If you enjoyed my today's video, then do like and subscribe to my channel. But don't forget to press the bell icon to get notified about my latest videos.